Imagine being on a journey through the cosmos, witnessing barren, lifeless planets as far as the eye can see. Now picture one extraordinary world, our Earth, a planet where life not only exists but thrives. This is no ordinary coincidence, it's a cosmic miracle, a delicate balance that has allowed life to flourish in ways we can barely comprehend. Earth stands alone in the vast darkness of space, offering the perfect conditions for life. But why? What makes our planet so unique? Today, we're going to uncover the secrets of Earth's rare and miraculous design, and how it has defied the odds to become the cradle of life in the universe. In this video, you'll embark on a fascinating journey across time and space to discover the incredible features that make Earth a one-of-a-kind oasis in the cosmos. From its formation billions of years ago to the fine-tuned factors that make life possible today, you'll learn about the forces that shaped our planet. We'll explore the magnetic shield that protects us from deadly cosmic radiation, the atmosphere that acts as a life-sustaining blanket, and the perfect distance from the sun, often called the Goldilocks zone, where temperatures are just right for liquid water to exist. All these factors and more work in harmony to support life as we know it. In this exploration, we'll also reflect on Earth's fragility, the impacts humans have had on the planet, and what the future might hold. By the end of this video, you'll not only understand why Earth is so special, but also gain a deeper appreciation for the world we call home. Get ready to see Earth in a way you've never seen before, from its cosmic origins to its critical role in our search for life beyond. This is the story of our planet, and it's one you won't want to miss. Earth's position in the solar system is nothing short of a cosmic stroke of luck. It orbits the sun in what scientists call the Goldilocks zone, a region that's not too hot and not too cold, but just right for liquid water to exist. This narrow band around a star is crucial for supporting life as we know it, and Earth sits comfortably within it. If we were just a bit closer to the sun, our oceans would boil away, and if we were slightly farther, they'd freeze solid. This delicate balance of distance means that Earth can sustain water in its liquid form, an essential ingredient for life. To truly appreciate how special Earth's position is, let's take a look at our neighbors. Venus, just one planet closer to the sun, is a hellish world with surface temperatures hot enough to melt lead, over 460 degrees Celsius. Its thick atmosphere traps heat in a runaway greenhouse effect, making it an uninhabitable inferno. On the other hand, Mars, which is farther from the sun, is a frozen desert. Temperatures there regularly dip below 60 degrees Celsius, and while there's water on Mars, it exists mostly as ice, locked beneath the planet's surface. Earth, by contrast, occupies the perfect middle ground, allowing water to flow freely, supporting life in all its diversity. This positioning isn't just a happy accident, it's what makes Earth a rare gem in our solar system, possibly in the entire universe. No other planet in our immediate cosmic neighborhood has the same perfect conditions. The Goldilocks zone is a delicate threshold, and Earth's presence within it is what allows complex ecosystems, from rainforests to coral reefs, to thrive. It's what makes Earth's landscapes vibrant, its oceans teeming with life, and its skies rich with breathable air. We often take it for granted, but Earth's placement in the solar system is one of the key reasons life has been able to flourish here for billions of years. This raises a fascinating question. How many other planets might exist in the Goldilocks zones of their stars? Astronomers are searching for such planets in distant solar systems, but so far, Earth remains unique in its ability to support life on such a massive scale. Our planet's position in the solar system makes it not just a home, but a rarity, a fragile oasis in the vastness of space. Approximately 4.5 billion years ago, Earth began its formation from a swirling cloud of gas and dust surrounding the young sun. This cloud, known as a solar nebula, was composed of hydrogen, helium, and heavier elements. Through a process called accretion, tiny particles collided, stuck together, and gradually formed larger and larger bodies known as planetesimals. Over time, these planetesimals continued to collide and merge, eventually giving rise to what we now call Earth. In its early stages, Earth was a molten, glowing mass of liquid rock, a fiery ball of magma with a surface temperature too high to sustain any solid ground. As Earth grew, it experienced constant bombardment by other space debris. One of the most significant impacts occurred when a Mars-sized body collided with the young Earth, an event believed to have led to the formation of our moon. This collision not only shaped Earth's rotation and tilt, but also accelerated the cooling process of its molten surface. The gravitational forces between Earth and the newly formed moon would later stabilize the planet's wobble, contributing to the relatively stable seasons we experience today. The intense bombardment continued for millions of years, gradually adding mass to Earth and shaping its surface. One fascinating aspect of Earth's early years is that its surface was once a vast ocean of magma. Imagine a world where molten rock dominated, with temperatures too extreme for any solid land to form. This period, known as the Hadean Eon, was characterized by violent volcanic activity and a thick atmosphere filled with carbon dioxide, nitrogen, and water vapor, making it an inhospitable place for life. The surface churned with liquid rock, creating an ever-changing landscape, as Earth was still in the process of cooling and solidifying. After millions of years, Earth's surface slowly began to cool, allowing a solid crust to form. This crust, however, was fragile and often destroyed by volcanic eruptions and asteroid impacts. Over time, as the planet continued to release heat, more stable crusts formed, giving rise to the first continents. These early land masses were frequently reshaped by the planet's internal heat and volcanic activity, but they marked the beginning of Earth's long transformation into a planet capable of supporting life. As Earth cooled, volcanic gases released vast amounts of water vapor, carbon dioxide, and other gases into the atmosphere. Eventually, this water vapor condensed, leading to the formation of Earth's first oceans. These oceans would play a crucial role in shaping Earth's climate and creating the conditions necessary for life to eventually arise. Though Earth was still far from being a habitable planet, the cooling and the solidification of the crust were pivotal steps in its transformation from a chaotic, molten world to the stable, life-supporting planet we know today. Deep beneath the Earth's surface, our planet hides an extraordinary feature that is crucial for life: its magnetic field. This magnetic field is generated by the movement of molten iron and nickel within Earth's outer core. As the liquid metals churn, they create electric currents, which in turn generate a powerful magnetic field that extends far into space, surrounding our planet like an invisible shield. This magnetic shield, also known as the magnetosphere, is one of Earth's most critical defenses against the harsh environment of space. Without it, Earth would be exposed to the sun's deadly solar radiation. The sun constantly emits streams of charged particles, known as the solar wind. These particles, if unchecked, would strip away Earth's atmosphere over time, much like a sandblaster eroding rock. The magnetic field, however, deflects these particles, guiding them around the planet and preventing them from reaching the surface. It's this invisible barrier that preserves our atmosphere, keeping it thick and stable enough to trap heat and sustain life. In essence, the magnetic field acts as a cosmic umbrella, shielding Earth from the relentless solar wind and preventing our atmosphere from being blown into space. To understand just how vital this magnetic shield is, we can look at our neighboring planet, Mars. Long ago, Mars had a magnetic field, a thicker atmosphere, and possibly liquid water on its surface. However, when Mars lost its magnetic field, likely due to the cooling of its core, it became vulnerable to solar radiation. Over time, the solar wind stripped away much of Mars' atmosphere, leaving it the barren, desolate desert we see today. This loss of protection is one of the key reasons why life, as we know it, never developed on Mars. Earth's magnetic shield, by contrast, has protected our planet for billions of years, making it a safe haven for life. One of the most visible effects of Earth's magnetic field can be seen in the form of auroras, or the northern and southern lights. These breathtaking displays occur when charged particles from the sun are funneled by Earth's magnetic field toward the poles. As these particles collide with gases in the upper atmosphere, they produce the glowing lights that illuminate the sky. While beautiful, these auroras are a direct reminder of the constant bombardment Earth faces from solar radiation, and of how our magnetic field protects us from its harmful effects. Interestingly, Earth's magnetic field is not static, it changes over time. The magnetic poles have even flipped several times throughout Earth's history, a process known as geomagnetic reversal. While these reversals take thousands of years to complete, scientists are monitoring the gradual weakening of our magnetic field today. This leads to the intriguing question: what would happen if Earth's magnetic field were to weaken further or disappear altogether? While such a scenario is unlikely in the near future, it reminds us of how vital this invisible shield is to our survival. Earth's atmosphere is a finely tuned mix of gases that creates the perfect conditions for life. Composed of 78% nitrogen, 21% oxygen, and small amounts of other gases like carbon dioxide, argon, and water vapor, this unique blend not only sustains life, but also shields us from the harsh realities of space. Oxygen is, of course, vital for most forms of life, allowing humans, animals, and even plants to breathe. Nitrogen, though often overlooked, plays a crucial role in stabilizing the atmosphere and supporting plant growth through the nitrogen cycle. This precise balance ensures that life can thrive, and even slight changes to this composition could have drastic effects on Earth's ecosystems. One of the most critical roles of the atmosphere is its ability to protect life on Earth from harmful solar and cosmic radiation. The upper layers of the atmosphere, particularly the ozone layer, act as a shield, absorbing and deflecting ultraviolet rays from the sun. Without this protection, the surface of the Earth would be bombarded with radiation, making it almost impossible for life to exist as it does today. This atmospheric protection works in conjunction with the magnetic field, creating a double layer of defense that allows Earth to maintain a stable environment, free from the dangers of space radiation. The atmosphere also plays a key role in regulating Earth's temperature through the greenhouse effect. Think of the atmosphere as a giant, life-sustaining blanket. During the day, it traps just enough of the sun's heat to keep the planet warm, while at night, it helps to retain that heat, preventing Earth from freezing over. This delicate process ensures that temperatures remain within a range that supports life. But just like a blanket, if it's too thick or too thin, it becomes problematic. If the atmosphere trapped too much heat, Earth would become unbearably hot, much like Venus. If it allowed too much heat to escape, Earth could plunge into an icy wasteland like Mars. Earth's atmosphere strikes the perfect balance. It's thick enough to retain warmth and create a stable climate, but not so thick that it traps excessive heat. This balance is what makes our planet so unique compared to others in the solar system. Venus, for instance, has a runaway greenhouse effect where its thick atmosphere of carbon dioxide traps so much heat that surface temperatures reach over 460 degrees. Mars, on the other hand, has a thin atmosphere that cannot retain enough heat, leading to extreme temperature fluctuations. Earth sits in the perfect middle ground, where temperatures are just right to support diverse ecosystems and life forms. Another remarkable feature of Earth's atmosphere is its oxygen content, which makes the air breathable for most life forms on the planet. This is a rarity in the universe. Oxygen is a reactive element, and without constant replenishment, primarily from plants and photosynthesizing organisms, it would quickly bind with other elements, leaving the atmosphere devoid of this critical gas. This creates a fascinating symbiosis between Earth's atmosphere and its life forms. Plants produce oxygen through photosynthesis, while animals and humans use that oxygen for respiration, maintaining a balanced and self-sustaining cycle. Despite its resilience, Earth's atmosphere is fragile and sensitive to changes caused by human activity. The increase in greenhouse gases like carbon dioxide, methane, and nitrous oxide, primarily from burning fossil fuels, has led to a thickening of the atmospheric blanket, trapping more heat and contributing to global warming. The depletion of the ozone layer due to man-made chemicals is another example of how human actions can disrupt the delicate balance of Earth's atmosphere. It's a reminder that while the atmosphere has protected life for billions of years, it is not immune to the consequences of human impact. Water is the foundation of life on Earth. Covering 71% of the planet's surface, it plays a central role in regulating climate, supporting ecosystems, and sustaining all forms of life. What makes Earth truly unique in the cosmos is its abundant supply of liquid water. While there may be traces of water in the form of ice or vapor on other celestial bodies, Earth is the only known planet where liquid water exists in such vast, stable quantities. This liquid water is critical not only for hydration and biological processes, but also for creating and maintaining the planet's climate systems. A continuous loop. Water on Earth is constantly moving through a natural process known as the hydrological cycle, or the water cycle. This cycle is an endless loop of evaporation, condensation, and precipitation. It begins when the sun heats the water in oceans, lakes, and rivers, causing it to evaporate into the atmosphere. As this water vapor rises and cools, it condenses into clouds. Eventually, the water returns to Earth in the form of precipitation, rain, snow, or hail, replenishing the land and oceans. This continuous recycling of water is what sustains life on Earth. Without it, water would remain stagnant and ecosystems would collapse. The water cycle starts with evaporation, a process driven by the sun's energy. Water from oceans, lakes, rivers, and even plants is transformed into vapor and rises into the atmosphere. Plants, through a process called transpiration, also release water vapor as they breathe. Together, evaporation and transpiration move vast amounts of water from Earth's surface into the atmosphere, forming the first step of this vital cycle. The air we breathe contains water vapor, and this moisture is crucial for regulating the planet's temperature and weather patterns. Once water vapor rises into the cooler regions of the atmosphere, it condenses into tiny clouds are responsible for distributing water across the planet. Clouds not only bring precipitation, but they also help regulate the Earth's temperature by reflecting sunlight and trapping heat. The formation of clouds is a delicate balance. Too much condensation can lead to storms and floods, while too little can cause droughts and arid conditions. This dynamic system is essential for maintaining Earth's ecosystems. Precipitation is the stage where the water cycle comes full circle. When clouds become saturated with water, the droplets combine and grow heavier until they fall to the Earth as rain, snow, or hail. This water then replenishes oceans, lakes, rivers, and groundwater reserves. It also nourishes plants and animals, maintaining the delicate balance of Earth's ecosystems. The global distribution of precipitation is not uniform, which is why some regions have abundant rainfall and others are dry. However, this imbalance is a natural part of the cycle, influencing the diversity of ecosystems around the world. After precipitation, water either flows over the surface of the land as runoff or infiltrates the ground, becoming groundwater. Runoff replenishes rivers, lakes, and oceans, while infiltration feeds underground aquifers. These aquifers store water that can be accessed during dry periods or used as a vital resource for human consumption and agriculture. Groundwater is also a critical part of the hydrological cycle as it slowly moves through the soil, eventually resurfacing in springs or seeping back into bodies of water. This process ensures that water is continuously cycled and available for ecosystems, agriculture, and human use. Water is the lifeblood of Earth's ecosystems. It supports plant growth, which in turn sustains animals and provides oxygen for humans. From the smallest microorganisms to the largest mammals, every living thing relies on water to survive. Oceans regulate the planet's climate, absorbing heat and distributing it across the globe through currents. Rivers and lakes provide fresh water for millions of species, while wetlands act as natural filters, cleaning water and preventing floods. Water's unique properties, its ability to dissolve nutrients, its role as a solvent, and its capacity to store and release heat make it indispensable for life. What makes Earth's hydrological cycle so extraordinary is its ability to sustain liquid water over billions of years. On other planets, such as Mars or Venus, water either exists as ice or vapor or has been lost entirely due to harsh conditions. Earth's perfect combination of atmosphere, distance from the sun, and magnetic field allows water to exist in all three states: solid, liquid, and gas. This dynamic water cycle has been crucial in shaping Earth's surface, creating diverse landscapes from deserts to rainforests, and allowing complex life forms to evolve. While the water cycle is a natural process, human activities have begun to disrupt its delicate balance. Deforestation, industrial pollution, and climate change are altering precipitation patterns, causing some regions to experience more intense droughts while others face flooding. The overextraction of groundwater for agriculture and urban development is depleting aquifers faster than they can be replenished. Understanding the importance of the water cycle is critical for preserving ecosystems and ensuring that future generations have access to clean, fresh water. Earth is teeming with life, from the smallest microscopic organisms that inhabit every corner of the globe to the largest creatures ever to exist, the mighty whales that glide through the oceans. This extraordinary biodiversity is one of the defining features of our planet. Every ecosystem on Earth, from rainforests to deserts, from coral reefs to mountain ranges, is home to an incredible variety of life forms, each playing a vital role in maintaining the balance of nature. Earth's biodiversity isn't just about numbers, it's about the interconnection of all living things. Plants, animals, fungi, and microorganisms are all intricately linked in complex food webs and ecosystems, where the survival of one species often depends on the survival of many others. Despite our advancements in science and technology, Earth remains a living mystery. Scientists estimate that about 86% of all species on Earth are still undiscovered. This means there could be millions of species, especially in the depths of the oceans and in the most remote rainforests, that we haven't even begun to explore. Every year, new species are discovered, from tiny insects to large mammals, reminding us that Earth's biodiversity is far richer and more complex than we can imagine. This statistic highlights how little we know about our own planet, even though we've lived here for millennia. Earth is like a vast library of life with countless books still waiting to be opened and read. Biodiversity is crucial for the health and stability of Earth's ecosystems. Each species, no matter how small, plays a role in maintaining the balance of an ecosystem. For example, pollinators like bees and butterflies are essential for the reproduction of many plants, which in turn provide food and shelter for countless other species. Predators help control the populations of prey species, preventing them from becoming too numerous and overconsuming the resources of an ecosystem. Even microorganisms in the soil play a vital role in breaking down organic matter and recycling nutrients. Without this intricate web of life, ecosystems would collapse, leading to a cascade of negative effects on the environment and on human societies. If we were to personify Earth, we could imagine it as a cosmic artist, painting life in vibrant colors across every possible canvas. From the deepest, darkest parts of the oceans to the sunlit peaks of the tallest mountains, Earth has filled every available space with life. It's as if Earth is driven by an unstoppable creative force, experimenting with countless forms and designs. The planet's landscapes are its canvases, and its creatures, whether they crawl, swim, or fly, are its masterpieces. Every living being, from the microscopic bacteria that live inside us to the towering redwoods that stand for centuries, is a brushstroke in the grand painting of life on Earth. Earth's biodiversity is astounding. There are approximately 8.7 million known species, but this number could be much higher due to the vast number of species yet to be discovered. Biodiversity includes everything from simple, single-celled organisms like bacteria, which are responsible for critical processes such as decomposition and nitrogen fixation, to the most complex multicellular organisms, such as elephants, whales, and humans. Then, there are ecosystems within ecosystems, like Corey's all species that rely on one another for survival. In and understanding phrase that used extreme environments like the Antarctic tundra or deep-sea hydrothermal vents, life flourishes in ways we are only beginning to understand. One of the most remarkable aspects of Earth's biodiversity is the ability of species to adapt to their environments. Over millions of years, life on Earth has evolved in response to changing climates, geographical shifts, and natural selection. This evolutionary process has led to the development of specialized traits that allow species to thrive in their unique habitats. For example, cacti have evolved to store water in arid environments, while polar bears have developed thick fur and fat layers to survive in freezing temperatures. Evolution continues to shape life on Earth as species constantly adapt to new challenges in their environments. This adaptability is key to the survival of biodiversity, but it is also fragile, and rapid changes can lead to extinction. Unfortunately, human activities have become one of the greatest threats to Earth's biodiversity. Deforestation, pollution, climate change, and habitat destruction are driving many species toward extinction at an alarming rate. The loss of biodiversity doesn't just affect animals and plants. It affects entire ecosystems and ultimately human societies as well. For example, the decline of pollinators like bees could lead to a global food crisis, as many of the crops we rely on for sustenance depend on these creatures for pollination. Protecting biodiversity is not just about saving individual species, it's about preserving the delicate balance of life that keeps Earth's ecosystems functioning. Biodiversity also plays a critical role in human life, providing everything from food and medicine to raw materials for industry. Indigenous cultures around the world have long understood the importance of living in harmony with nature, drawing on biodiversity for sustenance, shelter, and spiritual inspiration. Modern science, too, continues to discover new ways in which biodiversity benefits humanity, from natural pharmaceuticals derived from plants and animals to new technologies inspired by biological systems. By understanding and protecting Earth's biodiversity, we are also safeguarding our own future. In just a few thousand years, humans have become the dominant species on Earth, capable of reshaping entire ecosystems and landscapes. Unlike other species, we have the ability to alter the environment on a massive scale, thanks to our technological advancements and industrial activities. While this has brought incredible progress and convenience to human life, it has also led to significant consequences for the planet. Our actions are having a profound impact on Earth's delicate balance. affecting everything from the atmosphere and oceans to the biodiversity that once thrived uninterrupted for millions of years. As our global population continues to grow, so does our footprint on the environment. One of the most pressing challenges facing the Earth today is climate change, driven by human activities like burning fossil fuels and deforestation. These activities release vast amounts of carbon dioxide and other greenhouse gases into the atmosphere, trapping heat and causing the planet's temperature to rise. The effects of climate change are already being felt across the globe. Glaciers are melting, sea levels are rising, and weather patterns are becoming more extreme and unpredictable. If left unchecked, climate change could lead to catastrophic consequences for ecosystems, food supplies, and human settlements, particularly in vulnerable coastal areas. This is not just an environmental issue, it's a humanitarian crisis in the making. Humans are also drastically altering Earth's landscapes through deforestation and habitat destruction. Forests, which once covered vast portions of the planet, are being cleared at alarming rates to make way for agriculture, urban development, and industrial activities. This not only results in the loss of trees that absorb carbon dioxide, but also leads to the destruction of habitats for countless species. Deforestation is a major driver of biodiversity loss, as animals and plants lose their homes and are forced to migrate or face extinction. The Amazon rainforest, often referred to as the lungs of the earth, is one of the most affected areas, with large swathes of forest being lost each year. Human activities have also led to widespread pollution, affecting the air we breathe, the water we drink, and the land we rely on for food. Industrial waste, plastics, and chemicals are contaminating ecosystems and causing harm to wildlife. Oceans are particularly vulnerable to pollution, with millions of tons of plastic waste entering the seas each year. Marine animals often mistake plastic for food, leading to injury or death, and toxic chemicals from industrial runoff are poisoning entire marine ecosystems. Air pollution, primarily from burning fossil fuels, is causing respiratory problems for millions of people and contributing to global warming. The planet is slowly being poisoned, and we are seeing the consequences. Despite the challenges, the situation is not hopeless. Humans have the unique ability not only to harm the environment, but also to protect and restore it. Every individual can contribute to the preservation of our planet through small, everyday actions that collectively make a big difference. Conserving water by turning off taps when not in use, reducing single-use plastics by recycling, and cutting down on carbon emissions by using public transportation or cycling are all simple steps that can have a positive impact. Planting trees, supporting sustainable agriculture, and participating in environmental conservation efforts are other ways to help mitigate the damage we've done. These small actions may seem insignificant on their own, but when taken together, they have the power to shape the future of Earth for the better. One of the most effective ways to reduce our impact on the planet is by embracing sustainable living and transitioning to renewable energy sources. Solar, wind, and hydroelectric power are just a few of the clean energy alternatives that can reduce our reliance on fossil fuels. Governments, businesses, and individuals all have a role to play in accelerating this transition. By supporting policies that promote renewable energy, investing in green technologies, and reducing our energy consumption, we can significantly lower carbon emissions and slow the pace of climate change. Sustainable agriculture, eco-friendly products, and a circular economy where materials are reused and recycled are other essential components of building a more sustainable future. Education plays a crucial role in shaping how people interact with the environment. By raising awareness about the impacts of climate change, deforestation, and pollution, we can inspire more individuals to take action. Environmental education in schools, public awareness campaigns, and media coverage of environmental issues are all essential in driving positive change. The more people understand the fragility of Earth's ecosystems and the urgent need to protect them, the more likely they are to make informed decisions that benefit the planet. Knowledge is power, and with it, we can influence future generations to become better stewards of the Earth. While human activity has caused significant damage to the environment, there is hope. Around the world, conservation efforts are underway to restore damaged ecosystems and protect endangered species. Reforestation projects are planting millions of trees, marine conservation efforts are cleaning up oceans, and renewable energy is becoming more affordable and widespread. Governments are beginning to recognize the urgency of the climate crisis, with many countries committing to reducing carbon emissions and protecting natural habitats. If we continue to push for change and take collective action, it's possible to restore Earth's balance and create a sustainable future for all life on the planet. As the dominant species on Earth, we have a responsibility to protect and preserve the planet for future generations. Our actions have shaped the environment, but they don't have to be destructive. By taking small steps towards sustainability, embracing renewable energy, and raising awareness about the importance of biodiversity and conservation, we can make a positive impact. The future of Earth is in our hands, and we have the power to ensure that it remains a thriving, vibrant home for all species, including our own. The question we must ask ourselves is, will we rise to the challenge and safeguard the future of our planet? Earth teaches us what to look for in other planets. Scientists are now searching for Earth-like planets, known as exoplanets, to see if they might also support life. NASA's Kepler mission has discovered over 3,000 exoplanets, some of which are located in the habitable zone, raising the exciting possibility that we may not be alone in the universe. Earth, with its perfect combination of atmosphere, liquid water, and distance from the sun, serves as the blueprint for scientists searching for life beyond our planet. When we think about life elsewhere in the universe, we begin with what we know, Earth. Our planet has shown us the delicate balance needed to sustain life, from the right chemical elements to a stable climate. These discoveries have guided scientists in identifying what to look for when searching for Earth-like planets, known as exoplanets. The presence of water, an atmosphere, and the right temperature range are key factors, and they are the benchmarks for evaluating whether an exoplanet could potentially harbor life. For decades, scientists have been scanning the skies for planets beyond our solar system, planets that might share similarities with Earth. These planets, known as exoplanets, orbit stars in distant solar systems, and the goal is to find those that exist in the habitable zone of their stars. The habitable zone, also called the Goldilocks zone, refers to the perfect distance from a star where conditions might allow for liquid water to exist, neither too hot nor too cold. Earth, being in the sun's habitable zone, serves as the prime example of how this positioning can support life. By understanding Earth's properties, we've developed the criteria for what could make an exoplanet suitable for life. One of the most groundbreaking missions in the search for life beyond Earth was NASA's Kepler mission, launched in 2009. Kepler was designed to identify exoplanets by observing the tiny dips in a star's brightness as planets passed in front of it, a method called the transit technique. Over its 9 years of operation, Kepler discovered over 3,000 exoplanets, revolutionizing our understanding of how common planets are in the galaxy. Some of these exoplanets are located in their stars' habitable zones, which raises the tantalizing possibility that these worlds could have conditions similar to Earth, and maybe, just maybe, they could support life. The discovery of exoplanets in the habitable zone is one of the most exciting developments in astronomy. The habitable zone is the region around a star where temperatures are just right for liquid water, a critical ingredient for life as we know it to exist on the surface of a planet. While finding planets in the habitable zone doesn't guarantee the presence of life, it is the first step toward identifying worlds that could potentially be home to living organisms. Planets like Kepler 450 because they are located in their star's habitable zone and have characteristics that make scientists wonder if they might harbor life. Such discoveries bring us closer to answering one of humanity's oldest questions. Are we alone in the universe? In the search for life beyond Earth, scientists are not just looking for planets in the habitable zone, they are also searching for signs of life or biosignatures. These biosignatures include specific gases in an exoplanet's atmosphere, such as oxygen or methane, which on Earth are are produced by living line or unique sign or and with new telescopes like the James Webb Space Telescope, scientists can analyze the atmospheres of distant planets in more detail than ever before. The detection of these gases in an exoplanet's atmosphere could be the first real evidence that life exists beyond our solar system, sparking one of the most profound scientific discoveries in human history. Despite the advancements in technology and the discovery of thousands of exoplanets, finding life beyond Earth remains a complex challenge. Many exoplanets, even those in the habitable zone, are vastly different from Earth. Some may have atmospheres that are too thick or thin, while others might experience extreme radiation from their stars, making it difficult for life as we know it to survive. Additionally, the sheer distances involved pose significant challenges. Most of the exoplanets discovered by missions like Kepler are hundreds or even thousands of light years away, meaning that even if we could confirm the existence of life, it might take centuries or longer to explore these worlds up close. With Kepler's mission now complete, the search for life beyond Earth continues with new tools and missions. NASA's Transiting Exoplanet Survey satellite, TESS, is currently scanning the nearest stars for exoplanets, focusing on identifying those that are closer to Earth, making them easier to study in detail. The James Webb Space Telescope, set to revolutionize astronomy, will allow us to peer into the atmospheres of these distant worlds, searching for biosignatures and clues that might indicate the presence of life. In addition to NASA, the European Space Agency, ESA, is also conducting exoplanet missions, such as the Plato mission, which will focus on detecting rocky, Earth-like planets. Each new discovery brings us closer to answering one of the biggest questions in science. The search for life beyond Earth is not just a scientific endeavor, it's a philosophical one. For centuries, humans have gazed up at the stars and wondered whether we are alone in the universe. The discovery of even the simplest forms of life on another planet would fundamentally change our understanding of life itself. It would raise new questions about the origins of life, the potential for intelligent civilizations, and our place in the cosmos. Even if we do not find life, the search itself expands our understanding of the universe and pushes the boundaries of what we know. As we search for life on other planets, Earth continues to be our greatest teacher. The study of Earth's climate, biosphere, and ecosystems provides valuable insights into what conditions are necessary for life to thrive. By understanding how life has evolved and survived on our planet, we can better predict where life might exist elsewhere. Earth has shown us the resilience of life. It thrives in the deepest oceans, on the highest mountains, and in the most extreme environments. These discoveries give hope that life could exist in similarly harsh conditions on other planets, whether it's beneath the icy crust of a moon like Europa or in the clouds of a distant exoplanet. The search for life beyond Earth is one of the most exciting scientific pursuits of our time. As we continue to explore the stars and discover new exoplanets, we get closer to answering the age-old question of whether we are alone in the universe. Earth, our home, remains the model we use to search for other habitable worlds, and the discoveries made in this quest will not only expand our understanding of the cosmos, but also deepen our appreciation for the planet we call home. Whether or not we find life elsewhere, the search itself is a journey that inspires wonder, curiosity, and a greater sense of connection to the universe. As we come to the end of our journey through the wonders of Earth, let's take a moment to reflect on the extraordinary nature of our home planet. Floating like a delicate blue marble in the vast, dark expanse of space, Earth is a symbol of life and beauty. It's a reminder of how fragile and precious our existence is, an oasis in the emptiness of the universe. The more we explore the cosmos and uncover the harsh, inhospitable conditions of other planets, the more we realize just how rare and miraculous Earth truly is. Our planet's ability to sustain life, its perfect balance of elements, and its vibrant ecosystems all contribute to a cosmic masterpiece. We are incredibly fortunate to call Earth home, and this knowledge should fill us with both wonder and responsibility. The vastness of space can be overwhelming, with billions of stars and countless planets scattered throughout the cosmos. Yet Earth stands out not just for its beauty, but for its ability to nurture life in all its forms. As we continue to explore the universe, we might one day find other planets with conditions similar to ours. However, even if we do, Earth will always be unique. It's where our history is written, where life as we know it has thrived for billions of years. This journey through space reminds us of how interconnected we are with our planet, and how vital it is to protect and preserve this blue marble for future generations. Earth is more than just a planet, it's our home, and its story is our story. Looking ahead, we are faced with important questions about Earth's future. Human activity is already having a profound impact on the planet, from climate change to deforestation. But the question remains, what will Earth look like in the centuries to come? Will we be able to reverse the damage and restore balance to our ecosystems? Or will we be forced to look for another home among the stars? As we continue to explore space and search for other habitable planets, we must also remember that Earth is the only home we have right now. It is our responsibility to care for it, to protect its fragile ecosystems, and to ensure that it remains a thriving, vibrant place for all life.